Okay, so today, guys, we're looking at rational functions. And I'm just going to go over a couple of, slides that we should know. So this is the kind of stuff that we are going to talk about today. We're going to talk about, I'm sorry, I'm recording right now, so you should be having your notebook out and writing this down. Okay, so this is kind of what we are going to know and what you will know about rational functions. You should be writing this down. Okay, so first, we need to find the domain of rational functions. We need to find the domain of rational functions. Who remembers what domain means?
X values.
Okay, the x values, good.
Don't come here answering stuff.
Okay, we're going to find the vertical and horizontal asymptotes of graphs. So, yes, you should write everything that I have up here, you should write down in your notebook. I'm in the middle of recording currently. Okay, vertical and horizontal asymptotes. Anybody remember or know what that is? Okay, we're gonna talk about this today when we graph what asymptotes are. We're going to be able to analyze and sketch a graph of rational functions. We're going to sketch graphs of rational functions that have slant asymptotes eventually. And we're going to use rational functions to model and solve real-life problems. Okay? What really we're going to talk about today is just these first two. Okay? We're going to find domains. We're going to talk about vertical and horizontal asymptotes. And that's what's going to be your homework's going to be on. Okay? I do want you to write all this down and think about these are all the things that you will know how to do. And I will reference this page again.
So you write all of them down?
Yep. You can do them. Yeah, I will. It's in the future. Yeah. And again, this has all that. You can read my crazy writing. Okay. All right. So, do we got all this?
No.
Okay. Find the domains. Those are the x values of the rational function. Find the vertical and horizontal asymptotes. Analyze and sketch graphs of rational functions. Sketch graphs of rational functions that have slant asymptotes. And use rational functions to model and solve real-life problems. Okay, it looks like most people are done or almost done. Okay. All right. I want you to have these notes down mostly because I want you to have them in a separate place than just on the worksheet we're going to work on today, because I feel like this notebook you are less likely to lose and more likely to be able to find quickly. Okay, so we are going to go to talk about what a rational function is. Okay. A rational function is a quotient of polynomials. Quotient means what? Anybody remember what a quotient is? Division. It's division. Of polynomial functions. Polynomial means?
One.
More than one, actually.
Yeah.
So it's like, x squared plus 2x. That's a polynomial. Okay. It can be written in the form f of x, that stands for y or the function of x. Okay. of n over x over d over x. And the reason we use n and d is because this stands for numerator. I don't know if I'm spelling that right. And denominator. Okay? Where n and x are polynomials and dx is not the zero polynomial. So you can't have a 0 on the bottom, right? Because you guys remember, like 5 divided by 0, if you put that in your calculator, it'll say undefined. It's not possible. Okay? If I have 10 in my hands, I have 10 things in my hands, I can't divide it 0 times. Okay, that's not the same as dividing by 1, right? Can't divide it 0 times. I'm going to give you guys another minute because I want to make sure you're writing this down. I know that it's kind of hard when it's typed up for me to gauge how far it takes you to write, but we've seen my handwriting, right? Sometimes typed up is better. Okay. It's really important that dx, the denominator of our rational function, is not 0. That'll kind of tell us later on what the holes are in our graph, or it doesn't work. Okay? Finding the domain. Okay? We need to find the domain of the reciprocal function of f of x equals 1 over x, and discuss the behaviors of f near any excluded x values. Okay? Because the denominator is 0 when x equals 0, the domain of f is all real numbers except x equals 0. Okay, so here's where we're going to transition to our other notes and kind of try some of this out and talk about domain and how to graph this. You ready?
No.
Some of you are still writing this down. You're going to go to the other notes that I gave you, and we're just going to talk some about domains. Just want to make sure everybody gets this written down that wants this down, and then we're going to transition to our other notes and talk about domains. Okay, let's look at our notes right here. Now, this one says P and Q instead of NQ and DQ, or DX and NX, we say PX and QX. Back table, if you cannot handle being quiet while I'm taking notes, you can move. Okay, so Px and Qx are polynomials where Qx can't equal 0. So that's the same thing as we had in our other one, except we say P and Q instead of N and D. It's totally fine. The domain of a rational function is real except for those values where the denominator is equal to 0. So we're going to try some of those out. We're going to set the denominators of the rational functions equal to 0 and solve for x. Any real numbers obtained will need to be excluded from your domain. So let's try number 1 together. maybe number 1 and number 2, we're going to say 2x plus 1 equals 0. Do you guys see that? 2x plus 1 equals 0. Okay, now all we're going to do is solve for x. So we're going to subtract 1 from each side. 2x equals negative 1. Then we're going to divide both sides by 2. So x equals negative 1/2. Questions about that?
No, not at all.
Okay. Let's look at number, anybody besides Jordan have a question? Because Jordan said he's good. Anybody else? Okay. Number 2, we've got x squared minus 9. Do we remember how to factor that?
Yes.
Does somebody have a question?
Even.
Okay.
We'll multiply.
We've got x squared minus 9.
3 and 3. 3 negative.
So x minus 3 and x plus 3 equals 0. So while a lot of you have seen this factored, remember each one of these you set equal to 0 to solve. So x minus 3 equals 0 and x plus 3 equals 0. Okay? Remember when we talk about x equals negative 1/2, that means domain x cannot equal negative 1/2 when we talk about the domain. That's the whole point of us doing this, is to figure out what the domain is. Okay? So for each of these, I'm going to get x equals 3 because I add 3 to both sides, and x equals negative 3. So when I talk about my domain, x cannot equal 3 or negative 3.
Jordan said
I got it, Jay. All right, so example 3 is a little more difficult. We've got x squared plus 9 equals 0. Can I factor that?
yes.
No. Okay, because it's got that plus sign in there. So if we want to get x by itself, what do we do first? I heard it. Subtract 9. We got to subtract 9. So we get x squared equals negative 9. And then what do I do now? How do I get x by itself? I've got that squared. Not divide, but you.
Multiply.
So how do I get rid of a squared?
Square root.
Square root.
Oh.
Okay. So the problem is we can't take the square root of a negative number. So this is where I want you guys to see how we graph. So this might be a good time for you guys to take out your graphing calculators. And we are going, I'm going to try to make sure there's not a lot of glare. And we're going to put this in. So first thing I'm going to hit is Control Divide, and it makes that fraction. So should we start with how to get the graphing page?
No.
You're on the front, you hit B. A graph page shows up. You should get this little fx of 1 on here. If that doesn't show up, just hit the tab button. T-A-B. Okay, now I'm going to hit Control Divide, and it makes my fraction. And then I'm going to hit x plus 2 on the top and x squared plus 9 on the bottom. Then I'm going to hit Enter. Do we see the graph? Okay, now I'm just going to hit Menu and I'm just going to zoom in. Kind of so we can see this. Okay, and we can hit Zoom Fit if you want. And it looks a little bit different. Just an idea of where that zoom is. And we can even hit go back to zoom out so you can kind of see it a little bit better. Okay? So, you guys can see there's no hole in my graph anywhere. Okay, and it's because this is going to give me an imaginary number. Okay, so my domain is all real numbers. Okay, we know before this was hashtag, this was number. We're okay with that? Okay. All right. Let's talk about how to sketch this graph right here. So before you put it in your calculator and then just try to sketch it, let's talk about how we would do it without a calculator. First thing we talked about is how to figure out the domain. What can x not equal?
3, 4.
Let's look. This is just this for this right here. When is x going to be 0? When is the bottom going to be 0? When x equals what? 1 divided by -1 is just -1, isn't it? So that's not 0. When is x going to equal 0? When the bottom's 0, so x can't be 0. You guys with me? Yeah. Okay. Now let's simply like plug in some points. So this is back to like algebra 1 stuff. Let's plug in -3, -2, -1, 0, 1, 2, and 3. Okay? Just simple so we can see where it goes. Now remember, I'm going to get fractions, and you guys can graph fractions. I have confidence in you. Okay. So if I plug this in, I'm going to end up with 1 over -3. So that's -1/3. So if I go 1, 2, 3, I'm down just -1/3. Does that make sense?
Yes.
Plotting that first point, you guys are okay?
Are you going to plug the number into the equation?
Yes.
Yes.
So the next one I get -1/2. So for -2, I'm down 1/2, so a little bit more than 1/3. For when I plug in -1, I get -1. So at -1, I should have -1. At 0, I'm undefined though, right?
Yep.
Okay. At 1, I'm going to get 1. So at 1, I get 1. At 2, I get 1/2. So I'm right here. And at 3, I'm going to get 1/3. And it's right here. So here's the kind of the start of my graph, and I'm like, this looks funny. So now I'm going to pull up my graphing calculator. And what can you guys use at home if you don't have a graphing calculator? Do you guys know what the best thing to use is? You should probably write this down. Desmos.
Oh.
You guys have used Desmos before?
Root. You know Mr. Rowe?
Yeah.
That's your friend?
Well, I know. So this is Desmos, right? So I'm going to put it in here. So I'm going to put 1 over x. Should look like that. So we can also put that in our graphing calculator, 1 over x, so you can kind of see it. You might have to change your zoom. I'm going to change mine to zoom fit. And then I don't like that. Okay. So I end up with something like this. Okay. So do we see right here how it never crosses 0 and how it never crosses 0? Those right there are what we call asymptotes. So in this case, my horizontal asymptote and my vertical asymptote, how do I figure them out though if I don't have a graph? So let's turn the page and we're going to talk about them and then we're going to go back to that one. Okay? To find a vertical asymptote, it gives you the instructions right here. If you want to copy this to your notebook, because you're afraid you're going to lose this piece of paper, that's fine. But vertical asymptotes, gentlemen in the back, are right here. So we're on this page, right? Okay. We're going to get the function into the lowest terms. That means just like we did for this whole last chapter, we still have to reduce everything into the lowest terms, right? So that means you might have to factor, you have to simplify, all of that. Okay? Any real number obtained is a vertical asymptote. So we're going to solve the diameter equal to 0. So just like we talked about domain. So for this vertical asymptote, so if we go back here, what was the domain? What was x when we solved for 0? X equals 0, right? So my vertical asymptote is just x equals 0. That means if I was going to take a colored pencil, okay, this right here, that's my vertical asymptote in purple. So I like to do it in a different color. You guys can totally do it with just your pen. I just like to show it because it's easier to see up here on the screen. Okay. All right, let's go to horizontal asymptote because that's on the next page as well. Horizontal asymptote. Okay. So let's look because there's a lot of stuff here. So let's break this down. If the degree of the numerator is smaller than the degree of the denominator, then you will have a horizontal asymptote. So there's a lot of information here. So let's break this down. Numerator means the what? What does numerator mean again?
Top.
The top of a fraction, right? And denominator means the bottom of a fraction. Okay? So this is saying, and what does degree mean? Do we remember what degree means?
Yeah. The exponent?
The exponents, yep. Or those little numbers. Okay, so if the exponents or the degree is smaller than the exponents on the bottom, the horizontal asymptote is y equals 0. If the degree or the exponents of the numerator is equal to the degree of the denominator, then you have a horizontal asymptote at the leading coefficient over leading coefficient. And leading coefficient is the number in front of the largest x with the exponent. The largest number in front of the variable with the biggest exponent. Okay? If the degree of the numerator is larger than the degree of the denominator, then you do not have a horizontal asymptote. So do you guys see that you have 3 choices?
Yes.
Okay, so let's go back and talk about the horizontal asymptote for 1 over x. Okay, so if we're talking 1 over x, what is the degree of the top? How many exponents are on the top? I see a number on the top. I don't see any exponents. So it's 0, right? What's the degree on the bottom? I see 1 variable, so that means there's an imaginary little 1 right here, right? So that's 1. So I've got 0 and 1. This is my numerator and denominator. My numerator is smaller than my denominator, correct? So it says if my numerator is smaller than my denominator, my horizontal asymptote is y equals 0. So therefore, this has to be y equals 0. Okay, I know we don't have a lot of time, but I do want to go over one more because you're going to have to do this for your homework tonight, and I want to make sure you got it. Okay, so let's flip it over. We're going to do the last example. So we're going to go right here. We're going to do this. We're going to find the vertical asymptote, VA. We're going to find the horizontal asymptote, HA. We're going to find the domain, and we're going to do a quick little sketch of a graph, okay, where this is the x-axis and y-axis. Okay, so we're going to do all of that. Okay, first thing I'm going to have to do is I need to put this in the simplest form. That means I have to factor them. So I'm going to have x minus 1 times x plus 1, right? Because they're both perfect squares and subtracted. All over, I'm going to pull out an x. X times x plus 1. Do we agree these two x's cancel? X plus 1 and x plus 1? So we're just left with x minus 1 over x. So far, so good? What is the domain? Remember, the denominator can't be 0. What would make this denominator 0? So x cannot be 0. Otherwise, all real numbers. Okay. Now, to find vertical asymptotes, remember, it's right up here, your instructions. Vertical asymptotes, we set the denominator equal to 0 and solve for x. So what is the vertical asymptote? We took the bottom. We said x equals 0. That's it. That's all you got to do. The horizontal asymptote. Now let's look at the denominator versus the numerator. These are both, what are the exponents for both of these, x and x? 1. So does 1 equal 1? The numerator equals the denominator? So that means it's the leading coefficient over the leading coefficient. What's the leading coefficient? What's the number in front of each of these? 1. So my horizontal asymptote is 1. That means if we were to sketch our vertical asymptote, it's right here. Oop, it's right here at x equals 0. Yep. My horizontal asymptote is y equals 1. So if I were to put up a 1, there's my vertical asymptote. Okay? X cannot equal 0, so we're not going to cover that. And we've got x minus 1 over x. So this is where I can pull out my Desmos and be like, okay, I think I have an idea. So if I were to think about this, if I were to do this, I would think, okay, I think my graph is going to be right here and right here. But I want to make sure, so I bring out my Desmos, and I'm going to plug in the top to be x minus 1, and the bottom to just be x. And I'm going to hit graph it. Does that look right to you? Okay, so I'm going to go real close to those horizontal and vertical asymptotes, and I'm going to put it right here. It's just a sketch, so it does not have to be exact. Okay, so you guys have 4 like this for your homework tonight. Okay, so it shouldn't be too bad. Domain, horizontal asymptote, vertical asymptote, and graph it. I did give you a table below in case you want to plug numbers in, if that's easier. Okay, but you do not have to do that. All right, you can get started on that. You can put your calculators away when you're ready. We're all done.